For this lab, you'll force a convergence event on a switch that uses spanning tree protocol, and then force the same convergence event on a switch that uses rapid spanning tree protocol, and it'll go much faster. All right, details in the video. Let's go do a lab. As with all these ad hoc labs, all the instructions are here in the video. So what do I want you to do? Well, you're going to open this Packet Tracer file. It's linked in the description, so you can just download it and open it. And you'll see a topology like this with 4 switches. All those links will be up to begin. And all the switches use RSTP except Access 3. Access 3 uses spanning tree, and we're going to see a convergence event there that's slow. Access 4 uses RSTP, so we're going to do the equivalent convergence event there, and it's going to converge more quickly. So we're just going to compare those speeds. So let me give you a little more detail about what's going on there. Via the pre-configuration, dist1 is going to be the root switch. And on both of those 2 access switches, gig 111 is going to be the root port on each of those. And gig 112 is going to end up in a blocking state. It'll have no role from an STP perspective over here, and it'll be an alternate port from an RSTP perspective, and that's why convergence will happen faster over here on access 4. All right, so you have 3 major tasks, each with multiple steps for this lab. Here at task 1, what I want you to do is explore and figure out the topology. It won't necessarily take you a lot of time, but on each of access 3 and 4, make sure you understand what details I just gave you. So you can use these 4 commands: show CDP neighbor, show interfaces status, show VLAN brief, focusing on VLAN 10, and then show spanning tree VLAN 10. And we'll focus on the convergence just in VLAN 10. And I want you to pay attention to those 2 links that are connected up to the switches. This one on the left that'll be forwarding, and then we'll shut it down so it won't be forwarding anymore. And gig 112, which will be blocking to begin lab, and then it will eventually reach a forwarding state. All right, so figure that out. Make sure you're comfortable with the topology. At task 2, I want you to get ready to repeat the show spanning tree VLAN 10 command repeatedly. Up arrow, press enter, up arrow, press enter. Make sure you're comfortable with doing that. And pause for a moment and think about, on access 3, how soon will it pick a new root port and how quickly will it reach a forwarding state? In other words, how fast will convergence happen? Then ask yourself the same thing on access 4. How fast will that happen there? So to mentally think through the problem before you try it out. And task 3, you go do it. What do? You get into config mode for gig 111 and you issue the shutdown command to fail the interface. Then, taking a look at the second hand on your watch, you see how long it takes for this gig 112 port to reach a forwarding state. All right, that's the deal. Do the same thing on access 4. Shut down its root port. How long does it take gig 112 to reach a forwarding state? And that's the lab. Now I'm going to do a demonstration of each of those, but it's better for you if you'll go do it and try it for yourself. It is a lab after all, so spoiler alert, the demo happens next. So I'll give you a few seconds to hit pause so you can go do it for yourself. So here we've got the Packet Tracer file open. We've got our 4 switches, distribution 1 and 2, and access 3 and 4, and we're focusing on access 3 to start. So I've opened that up, and I've done a few commands already, but we'll start with task 1, which is to issue those 4 show commands and get familiar with the lab. So I'm going to up arrow and retrieve those and start with show CDP neighbor. Now, if you're following the course in order, we haven't talked about CDP, but it's a way to find out information about yourself and directly neighboring devices. So here on access 3, we see dist1 and dist2 as neighbors. That is, we have direct links to dist1 and dist2. And here on access 3 is using its gig 111 port to connect to dist1 and gig 112 to connect to dist2. Then if I up arrow a few times and retrieve the show interfaces status command, we look down at the bottom, those gig 111 and 112 ports I just mentioned, they're in a connected state and they are trunks, so they're supporting all the VLANs that we have, as it turns out. What VLANs are those? How about I up arrow a few times and do a show VLAN brief, and we've got the default VLAN, of course, VLAN 1, and also we've got VLANs 10 and 11. Now for 10 and 11, we've got 1 access port each connected to one of those PCs. Let me show you the diagram again. We've got PC11 and PC21. Each of those is in a different VLAN, 10 and 11. And then, of course, we've got those trunk ports connected up to the distribution switches. Now, we're going to focus on the spanning tree topology for VLAN 10 in the demo. Last command, show spanning tree VLAN 10. And if we look down toward the bottom, we see those two trunk ports. We see a gig 111 that connects to distribution 1. It's the root port in a forwarding state. And then gig 112, that's the one that's in a blocking state right now. Now, it turns out, even though this switch is using 802.1d spanning tree, it's still, Cisco's convention is to still list that port as an alternate port role. But because it's not using RSTP, it doesn't converge quickly. So this will be the port that will converge on and move to a forwarding state, but it'll be a little bit slow. So for task 2, I just want you to be ready to hit the up arrow and retrieve that show spanning tree command and keep repeating it over and over, and watch this gig 112 port and watch it change from blocking to a forwarding state. All right, so I've done that. Hopefully you're ready to do that. Up next, we want to then shut down that gig 111 port, our current root port. So I'm going to get into configuration mode here on Access 3 and get into config mode for interface gig 111. And I'm going to type the word shutdown, but not press enter yet. I'm ready to press enter. And over here on the right, I've got my stopwatch ready to click start. So I'm going to hit shutdown on the left and then hit start on the right as quick as I can go. So shutdown, click start. And now I'm back to the console of Access 3. Up arrow and do the show command, and notice it says LSN, which is how Packet Tracer abbreviates listen. And we're going through the 15-second mark, so I'm going to up arrow and see now we're in a learning state. So now we're in that second set of 15 seconds. Do it again. We're still in learning. Do it again. We're still in learning. One more time. Still in learning. We crossed the 30-second mark. Let's see if we made it to forwarding. There we are in a forwarding state, backing up the idea that we spend 15 seconds each in a listening and learning state during this transition. For this demo, I'm going to follow basically the same steps, but here on Access 4. As it turns out, on Access 4, it's the same topology, but I'm going to use RSTP on this switch. So at task 1, I said try those 4 show commands. I've done them before, so I'm up arrowing to retrieve those. Show CDP neighbors. We see dist1 and dist2. Off ports gig 111 and 112. If I up arrow again and get to show VLAN, let's see, show interfaces status next, and I look down at the bottom, I see I've got connected ports gig 111 and 112, and they're trunking. So we're supporting our VLANs 10 and 11 on those trunks. If we look at the VLANs themselves, show VLAN brief, we see VLANs 10 and 11 are active here on this switch. And by the way, we've got a couple of access ports connected to those VLANs. Looking back at the figure, we've got one PC each in those, PC12 in VLAN 10 and PC22 in VLAN 11. And then finally, let's look at the spanning tree. We'll focus on VLAN 10's spanning tree. And there you go. So we've got gig 111 as the root port in a forwarding state, and gig 112 as the alternate port. And because this switch really is using RSTP, it really is an alternate port, and it's going to converge quicker than we can do show commands to see it happening. It will immediately go to a forwarding state. So let's do that. Be ready. This is task 2, formally in the lab, but be ready to up arrow, and keep repeating the command over and over. And watch that gig 112 to see how quickly it moves to a forwarding state. All right. So task 3, we're going to shut down that root port. That's interface gig 111. I've typed shutdown, but haven't pressed enter. I'm ready to press enter. I'm going to get over here and get ready to click start. So I'm going to hit shutdown, click start, and then we'll start doing show commands. All right. So there's the shutdown, click start. And let's do that show spanning tree, and we're already moved over for gig 112 as the root port in a forwarding state. I knew that would happen, but it's way faster. It's sub-second in real life. So there you go. We've taken advantage of, Access 4 has taken advantage of that alternate port concept and converged almost immediately for gig 112 to be the root port and moved it immediately into a forwarding state. I hope you enjoyed doing the lab. If you want a little more depth about how all that convergence works, you can click on the left. That video tells you more about convergence with rapid spanning tree protocol. If you're ready for the next topic, you can get into spanning tree protocol configuration, the kind that I use to influence that spanning tree to make one switch be root and one switch win the designated port election. Click on the video on the right for that. Hey, thanks for hanging out. I'll talk to you soon.